Hello everybody and welcome back. In this video we're going to be learning about the metallic material inside Cinema 4D and Octane Render. Now, as per usual, before we begin, let's just go ahead and lightly talk about what we have in our scene right here. First off, we have an infinite floor object as our floor, a sphere as our object of interest with its segments set to 60, and I also have it raised above the floor 100 centimeters. Now, to light our scene, I'm using an Octane daylight object with a torpidity of 3 and a sun size of 30. I also want to point out that we do have our channel set to the path tracing kernel, so we are rendering with that. Now that we have all this out of the way, though, let's go ahead and start by talking about how do we make the Octane Metallic Material. The best way to do this is simply go to Materials up here and then select Octane Metallic Material. Once you've done that, just go ahead and drag and drop this on our sphere right here, and you'll notice right in our viewport we're getting a rendering of this going off right here. Now, let's go ahead and start by mentioning the main purpose of the Octane Metallic Material. Its main goal is to simulate the looks of metal, as its name would imply. So anything that's going to be made of metal, this is the material you're going to want to use. Now, I really want to start making a distinction between the metallic material and the Octane glossy material. They're very similar, and they both can make a similar effect and simulate the same types of properties, except they have a big distinction. The Octane glossy material can be used to make different types of metals, but it is limited and is not quite as good at making quite realistic looking metal materials as the Octane metallic material. The Octane glossy material is more geared to creating like a glossy coating that covers your object, whereas the metallic material is literally much better suited and designed to make literal looking metal materials. So let's just make sure we have that distinction. Glossy is for something creating like car paint, a glossy covering, whereas a metallic material is literally designed for making metals. So now that we have that out of the way, let's go ahead and open up our metallic material and start learning about it. Now, the first thing you're going to notice is there is some big distinctions in this material between this and our old Octane glossy material, which we learned about previously. One of the biggest things you'll notice is we now have something called a specular map and something else called an index of refraction mode, or IOR, and that is what IOR stands for, Index of Refraction. Now, the first thing I want to point out with this Octane metallic material is that the diffuse parameter here will not work and will not function at all unless you have something called your specular map turned down. Now, here is our specular map, and if I take this, we pull it back, notice we see that diffuse color, the diffuse base color, diffuse right here, red, showing through. Now, view your specular map is simply like a little map where you determine where the metal parts of your object are going to be, or where the shiny specular areas are going to be. Now, there's a big distinction between the specular map and the actual specular port here. Specular determines the strength of our reflections, right? But specular map determines whether we're actually having a metallic specular effect happening on this part of our object. So there is a big difference. If we have this maxed out, we simply are saying, okay, pull this to the bottom, we are having no reflections. It means we're not having any light bounce back, which means we are simply going into nothing. We have simply just a black color showing through. But if we take our specular map and we leave our specular pull to the top up here, we pull this back, we instead are saying instead of the specular effect happening, we are having another color bounce back instead, which is our diffuse base. What's really cool here is if we go ahead and take our specular map and pull it back up to the top, we can put in our own effect here by selecting this texture slot here and putting in something like generators, something called a noise. Now, we haven't really done much with noises yet, but just be aware that this is a cool effect that we can use. This is a special Octane noise, and don't get so hung up on how this is working if you haven't used noises yet. We'll be explaining that more further in the course, but just be aware that we're going to go ahead and click noise. We're going to open it up, just simply do what I do, and then we're going to take this parameter contrast, and we're just going to pull this up a little bit just to create some contrast. And don't worry, there is a scene here. I'll show you how to remove that later on in the course, but just be aware that we can now preview different areas of our material. Some part is metallic, here's the metal part, and some part is more of our diffuse. So we're actually controlling the different more metal, specular, metallic areas that are showing up. Now, this said, this doesn't mean this whole thing still couldn't be viewed as metal. For example, this is a great way of allowing rust to show through. I could have a really nice rust map shown up on the diffuse map here. I could load in like a really cool looking rust image texture in here or something like that. And then for our specular map, we could allow a noise or something like this to fade in between that rust and that specular. So we can kind of morph between that, so we can create some kind of like nice fresh metal here that has no rust, and then a more rusty spot here. And again, we can go to our diffuse parameter here and change this color as we wish. Now, I also want to point out this same exact effect takes place as it does with other materials as far as the color and the float. If we have any type of color in here, our float has no effect, but if we get rid of color, our float takes over. So remember, color supersedes the float, and our float can only work if our color is off. Now, in some cases, let's go ahead and turn this back up to a nice blue. In some cases, like our specular map, for example, let's go ahead and remove this right here. We'll just clear it out. There is no point in loading in any color because a specular map is a grayscale system. It only does white and black and anything in between. There's no point loading in any color, just like our roughness map, which is something we've learned about before. And I just want to point out, roughness on here is exactly like the glossy material. So again, you go ahead and increase a value here. We make this pure white, pure rough, or pure black, no roughness. The same thing can be done with our float texture here. If I add any color to this, it has really no effect. We can change our value of roughness, but it's really not an efficient way of adjusting roughness whatsoever, so I don't really recommend doing this way. So let's go ahead and pull this down, get rid of this, disable the color, and run this under our float. Now that we understand this, though, let's go ahead and hop over and talk about this effect right here, anisotropy. Now, I might be pronouncing that wrong. It might be anisotropy, however you want to pronounce this. This effect is something we talked about with the Octane glossy material, and it functions exactly the same. Now, in case you aren't sure what an anisotropic effect is, it's simply that kind of weird different reflection patterns and changing of how the reflections look, similar to the bottom of like a frying pan or the floor of like a truck or something that has like those bent metal kind of patterns and different things that go on. Once I turn this on, you'll kind of see what I'm talking about. So what anisotropic does is it simply creates different angles and variation in the reflections to create interesting designs on there. This is very, and importantly to understand, this is very distinctly different than a bump. A bump is actually going to create fake surface details. So it's actually going to make like the surface is actually bumped, indented, where we can actually see shadows and light fall off and all that. This is simply changing the angle of the reflections, and that is it. So let's go ahead and give this a try. We'll select our anisotropic effect here. What we're going to do is we have to actually apply the little pattern that is going to adjust the shape of that effect. So we go ahead and click this arrow. We can load in whatever we want. We could do a noise or anything like that. I'm just going to go to C4D Octane, and again, we're going to grab a noise, and that's in this here. This is listed alphabetically. MN, here it is, noise. Now again, if you don't know how to use noise, that's okay. Just simply do what I do and realize we're going to be learning more about it later on. So we're going to select a noise, go in here, crank up our contrast, something about, I think I like a value of 5, and you might notice nothing's happening. Just like with the glossy material, it's very important that we select our anisotropic effect and we actually give it some power. So let's go ahead and type in a value of something like 0.3. Now again, we're still not seeing effect, and that's because we actually have to have some roughness to actually help bend the light and see this effect happening. So we're just going to select our float right here, pull this up, and let's go ahead and just set it to a value of something like 0.2. And again, you're going to notice we're still seeing nothing. Why is this? Just like with our glossy material, the anisotropic effect is only compatible with the new BRDF models in Octane. So we need to select our BRDF model and change it from the default Octane one to one of the more realistic BRDF models, such as Beckman, GGX, or Ward. Now, GGX is specifically designed for metal-like materials, so I'd recommend us using that one in this case. So let's go ahead and select it. And now you can finally see the noise effect actually taking place. And you can see we're getting this interesting variation in our reflection. So this is what an anisotropic effect looks like. And again, I'm not going to go into too much detail on this because it's something we've already talked about with the Octane glossy material, and it's basically pretty straightforward. You can get different designs, different techniques in here, change the look of this. I could go ahead and change this anisotropic effect, pull it this way, increase the effect of it. If I really intense it all the way to -1, we get this really strong anisotropic effect where it's this hard, distinct angle and change in the direction of that light being bounced. Or I can reverse it and have it the other way. So pull a positive one, it'll look like this, or I can invert it and do negative one. Or we could do anything in between and just do a very, very light amount. So this level of reflection detail we're getting on here, again, I want to make sure you understand the distinction between this and a bump. This is just the light's reflection being changed. Notice we're not actually seeing shadows. It doesn't look like it has any depth. This is just the reflection being changed, not actually creating bumps. So if I took this actual noise, let's just go ahead and copy this shader. Clear it out, so we've removed it. Let's go ahead and down to bump. I will point out, yes, this does support bump, and if we do go here and we paste in this effect right here, where is it? Paste. This is bump, right? This is what a bump looks like. We're actually creating fake surface shading detail on here, so we're actually seeing shadows. The material looks like it's being bumped out, and we have different effects going on here. So again, I am showing that bump does work, and this is what bump does. But again, let's make sure we realize the difference between bump and the anisotropic effect right here. Now let's go ahead and remove this and move on. Right below that is to Sheen Layer. And Sheen Layer, just like with the Octane Glossy material, same exact thing, is it creates a sheen effect on your material, very similar to that like light shining on something like velvet or cloth. Now, a big gotcha in this Octane Metallic Material with Sheen is that it will absolutely not show up on your material unless you have your Specular Map pulled back a bit. So let's go ahead and pull our Specular Map all the way back to 0. Take our sheen layer, and we have to load something into the texture, some type of sheen color to show through. So let's go ahead and select this, C4D Octane, whoops, and we're going to go all the way down to RGB spectrum. Select into our RGB spectrum, and this, if you don't know already, an RGB spectrum node is simply just a raw color input. So let's just go ahead and set this to pure white, go up one layer, and now if we increase our roughness value, we can see this sheen effect kind of shining around the edges of material. Again, creating like this type of cloth effect. Very popular and easy to use with the Octane Glossy material as well. Now again, this is controlled, the amount we're getting is controlled by our sheen roughness. If I pull this to 0, we don't see it all, and as I increase it, we're allowing more of this sheen roughness to show through. Again though, if I go to my Specular Map right here and increase this float value, we're going to start to lose the sheen effect because sheen is an effect that happens on top of diffuse. And again, Specular Map overrides diffuse. So if I have my Specular Map maxed out, it's going to override diffuse, which in turn will override our sheen layer. So if we want our sheen layer to show up, we have to pull our Specular Map back up to allow that to come through. This does give you the potential to create some type of like metallic layer that's covering like cloth. It would be a very interesting effect. Again, you can control this, drag it up, go ahead and here, go to generators, add a noise, and then through here we can increase the contrast. And again, we're transferring, I'm going to really increase the contrast. We're getting that sheen effect going through on our diffuse color. There's the blue with our metallic effect happening on here, which of course, if I wanted, I could also hop into our anisotropy effect right here, and again, also add a noise, C4D Octane noise, here it is, and of course, we could increase the contrast on this a little bit, and we could hop into our anisotropic effect and pull that up. So again, you can see how we can layer and stack this to create more and more robust effects. So we're adjusting our metal section, right? And then we do that as we normally would, right? Just create the anisotropic effect. But now we are able to adjust our specular map and then determine what part shows through. So you can see this gives you a lot of control as far as adjusting the specular parts versus the diffuse parts. This gives you a lot more control than if you're working with a simple glossy material where you just have like a glossy coating. This is actually a really easy, cool transfer you can do from reflective to non-reflective sections of your material. This is a very unique example, of course, that's not very realistic, but again, you have a lot of potential with this. Now that we understand all this, though, let's go ahead and move on to film layer. This is another effect that we've already learned about with the glossy material. It's the same exact thing, functions the same exact way, so I'm not going to go into too much detail on it. But to help learn about, let's go ahead and go back to our specular map and just go ahead and clear this noise out so we can focus back on this. Let's take our anisotropic effect and zero it out to disable it and just go ahead and remove our noise right here. So again, the film layer, or also referred to as the thin film layer in the glossy material, does the exact same thing. What it does is it creates the effect of a tiny thin film covering the surface of your object, similar to like a light thin layer of like oil on top of like gasoline that would be laying in the road or something, where you get like this rainbow effect over it when you look at it. Creates an effect just like that. So if we go ahead and take our float value and increase this, this determines the thickness of our thin film, or the perceived thickness. Now I want to be very clear here. This is very similar to bump, as this is actually creating a fake surface shading detail. Like with bump, we're not actually displacing any geometry or creating any imperfections or dents into our object. We're simply giving the illusion that there is a thin film on top. So we don't actually have to create one, which is nice. We don't have to worry about rendering a tiny little thin film layer on here. We can just fake that and give the illusion of such to give us the nice visual example here. So to do that, if I increase our float value here, let's go ahead and do something like 0.2. This gives us a thin film kind of index of refraction here on this, right? So 0.2. This gives us this really cool kind of blue to green effect here, and kind of like a light teal green going in between here. Now we have film IOR, or film index of refraction. This determines the refraction rate for our thin film that we've already set here. So here's how thick it is, 0.2 centimeters, millimeters. I'm not really sure what value this would relate to, but here determines what refraction rate that it's bouncing off of. At what angle is the light bent when it hits it? So if I pull this back to 1, we're going to have a pure redirect of light. All the light that hits it bounced directly back wherever it came from. And you can see this is the strongest example. And as I crank up our thickness here on our float, you can see we're getting more and more layers of color that just come through. And you get this really crazy look in here, which again, this is all completely controlled with the specular map. So if you drop that off, you completely remove it. And again, through in here, you can go to generators, noise, and you can crank up the contrast and link them all together. Again, this is giving you a lot more control than you did with the glossy material. So depending on what you want to create, you might want to go ahead and go with that metallic material. Let's go ahead and go to our specular map. Again, clear this out. And let's go ahead and go back down to our film layer. And if we take our film index and we kind of crease it up, we can start to kill off those reflections. Now, if you go too high, it just blows it out and turns it into a gray mess. We're reflecting the light in so many different ways at so many different angles. It just kind of gets all messy. So you want to use this lightly. But if we go ahead and use a smaller value, like the default 1.45, it gives us a very nice effect right here. And again, if I take our float value and drop this to 0, it's going to completely disable the effect because we have no thin film here. It's completely zeroed out. You might be wondering, though, why am I still seeing color here? This is because, like with the glossy material, Cinema 4D has a bug where if you're just dragging this value and quickly pull it over, the live viewer doesn't have enough time to update that effects change to actually preview what's actually happening. So the way to fix it is simply resend your scene, and instantly it's going to be previewed correctly. Another thing I want to point out that has been added is we now have control to this texture slot here. So we can actually control this float value instead of just a raw, this is how thick it is. We can control how thick it is at different parts. So if I go to texture right here, go to, let's say C4D Octane. Let's use an Octane noise. We'll just go ahead and grab a noise, increase our contrast, and lo and behold, we are controlling our noise thickness throughout this. Now, I cranked it up way too high, so I'm just going to go ahead and pull this back a little bit. So now you can see we're getting some color effects here, some effects here. We can go up one layer, and we're going to go take our index. We can adjust that. I can pull that back to 1, which is going to give us a crazy, crazy look. As you can see, this is a very interesting look. And I do want to point out, this is still a thing now with the glossy material as well. So I just want to point out the ability to load a texture into this slot now should still be capable with the glossy material as well. So let's just go ahead and select a glossy material, film layer, and we do have this control here. So this is a new effect, part of the latest Cinema 4D version 3.08, or I think whichever version I have, the latest one it is. This is a new standard feature for all these available controls. So I'm just going to go ahead and select our glossy material, delete that, and go back to our metallic. And we can go ahead and clear this noise from this film layer right here. Next up is bump. We've already learned about that. Normal, this is something we have covered with all the other materials. That functions just like bump, except uses a normal map. Same effect here, nothing special. Displacement. Displacement with the metallic material functions exactly the same as it does with every single Octane material. So that is why I have its own distinct video dedicated to explaining that in this section for materials. So go ahead and check out that video. It's below this. It's the video talking about only displacement. So that one video will cover the process and how displacement works for every single material. Next up is opacity. This is pretty self-explanatory. It lets us determine how opaque our object is. If I take this float value and pull it down, it is now completely transparent or not opaque at all. 0% opaque, completely invisible. 100% opacity. Now, if we increase this value back to 1, it is 100% opaque or 100% visible. So now we can also adjust this again through color. So I could go ahead and drag this up, 100% visible, black, 100% invisible, not seeable. And if I drag this to 0, it disables the color effect and we run over the float. Now again, opacity runs under a grayscale system. So adding color has no effect. It will give us different levels of being opaque or not opaque. But again, it's the same thing as if we just dragged a black and white slider up and down. So adding color is pointless, and it's better to run under a black and white float system like this right here. Now that we understand this, though, let's go ahead and move on to IOR mode. Now, the IOR mode is a very distinct specific mode that is only available with the Octane Metallic Material, and it is what actually separates it from all the other materials and makes it very distinctly useful. This particular mode right down here, just this little slot right here, is one of the main reasons why you're actually going to be even using the Octane Metallic Material. You'll notice that if you've gone ahead and use, let's go ahead to materials here. If you've gone ahead and used the Octane Glossy material before, you'll notice that this spot right here is the index parameter, and this is where we're able to adjust the reflection fall off on our sphere. How hard are the angle of the light that hits our sphere? How hard is that bent and reflective? If I have this set to 1, it's a perfect 1-to-1 ratio. It hits it and it bounces straight back. And as I increase this value, we start to bounce the light away. Now again, as we start with like a really low value, we're not bouncing the light very much at all, and you have to hit at a pretty hard angle for that light to show up. So again, the light, this determines what angle does the light have to hit this sphere for it to actually show up. Now what's very interesting here is if we crank this all the way up to a value of like 8, we're allowing the light to hit from all kinds of angles for it to show up. But if I set it to a value of 1, it's showing up perfectly. Now, this is actually not physically correct. A value of 1 should actually be no angle is able to show up, right? It has to be a value higher than 1 for the angle to actually show up and be correct. So again, the Octane Glossy material is nowhere near as physically correct or physically accurate as the Octane Metallic Material, because again, this value of 1 should be no reflections, but this is its way of just defaulting to purely reflective, where realistically we shouldn't see any reflections, because at this angle, there's no light should be able to hit from a hard enough angle for reflections to show up. And as I go above this value, we then allow more reflections to show through. And as I go higher and higher, more and more reflections are able to show up from more of an angle. So as I increase the angle that reflections are allowed to be perceived through, we start to see this. Now, let's go ahead and close our Octane Glossy material and hop back into our metallic material, which is now in the IOR mode. You might notice, okay, cool. So now with that information, we realize that this material is going to be much more physically accurate. So the first thing I want you to understand is that Octane Glossy material, again, and how it perceives and bounces around those reflections with that index parameter. Go ahead and take all the info that you knew about that and throw it out the window, because this IOR mode inside the Octane Metallic material is very distinctly different, because it's based on principles that are much more physically accurate and physically correct. So if we go ahead and take these little sliders here, you might think they do the same thing as the index value did. And if as soon as we start dragging them, you're expecting a result. And sadly, what we're going to get right off the bat is nothing. That is because under the current reflection mode, which is referred to as artistic, disables these sliders. So this slider and this slider do not function when you're on the artistic mode. Now, if I select this drop down here, you can see we actually have 3 modes to choose from. We have artistic, IOR plus color, and RGB IOR. Now, what's interesting is the topmost parameter, artistic, is the least physically correct mode that you can choose, but as its name implies, it's very artistically easy to use. So if you want to go ahead and just do a very simple material and you don't care about being very physically accurate or physically correct, or don't really care about it, realism as much with your material, you can go ahead and just leave it on artistic, and you can make controls very easily. It'll just be purely reflective like it is, and you can just change all the parameters in here, like specular and everything else we've done in this video so far is all completely capable with the artistic mode. This said, if we change this to something like index of refraction plus color, we then get controls like we had with the glossy material to adjust what angle does the light have to hit our sphere for this reflection to show up. And plus, we have control of every other parameter that was our system, such as our specular color. So we could go ahead and set a nice color such as a nice gold color. So we'll type in a value of, say, 50 here on our hue. Now you might be wondering, I just set a gold color. Why isn't anything showing up? Because if I was in my IOR mode and I had artistic set, well, lo and behold, there is our color. Why isn't this showing up with our IOR plus color option here? We're just getting this pure white reflection here. This is because we have to define at what angle do the reflections show up to allow that to show through. I actually have to increase this value to allow light to have enough of an angle to show through. So if I start pulling this value up, you're going to start to see this little kind of golden circle showing up on our sphere. That's because this value right here, 0.177, is the angle that I'm allowing light. So if light hits our sphere at this small amount of an angle, which it is only a small little part of our sphere, it will then allow that color to bounce back. Now, I do want to lightly touch on the fact why we're actually seeing a purely reflective sphere and then changing to color. You might actually be wondering, if this is the area where I'm allowing light to reflect back off of my sphere, why is everything else purely reflective? Shouldn't light only reflect off of this spot? We're actually adjusting the index of refraction for our color. Think of the plus as a 4. Index of refraction for our color. I'm saying only at this angle is this light able to be bounced back in this color. Now, to help explain this, I'm going to lightly touch on how light works in the real world. In the real world, let's go ahead and set our index of refraction back to artistic. In the real world, light that comes from our sun is made up of all the colors of the rainbow. This is referred to as white light. This is pure white light that has all of the colors of the rainbow, red, green, blue, purple, violet, orange, all mixed together in one perfect beam of light. Now, when this perfect white light hits something, like say, oops, I'm changing my diffuse color. Let's go ahead and change our specular color, let's say to red. Say when this pure white light hits something like this red shiny sphere right here, we see red light bounce off of this. How is this possible? Well, this is because that white light hits this sphere. And remember, that white light is made up of all these colors. Any white light has red, green, blue, purple. It has all of that information in it. It's just simply hidden when they're all clustered together and it looks pure white. But when you separate those rays, you can see the color. So when that white light hits this sphere, what's actually happening is this sphere is absorbing all the colors in that white light except for red. So every color in that rainbow spectrum is absorbed and only the red light is bounced back. So if I set this color to green, the same thing is true. Every color is absorbed except for green. Same thing for blue. Every color is absorbed except for blue and only the blue light is bounced back. So let's go ahead and set this back to just a purely reflective, pure white. So all that light is bounced back perfectly. So if I set this to white, all the white light that hits it, red, green, blue, and all those colors that make up that light are also bounced back with it, and we don't see any color. Now, if I go back to IOR mode and set this from artistic back to IOR plus color, we can see that we're getting a little grayish tint in here. And this is because this is actually just simply saying, okay, we're going to have less of that pure white light come back, and it's just going to be a little bit darker. So if I go ahead back to my specular controls up here and change this to an actual color, like say green, for example, you can see we're getting this green color. And that's saying, okay, anywhere light hits on this sphere, it's going to be purely reflective. Everything will bounce back perfectly. But when light hits this sphere, it's going to be warped and bent to this bit of an angle here. And only from this angle are we able to actually perceive that light. Only light that hits the sphere from this angle is it actually able to be seen. So again, light that hits our sphere from this angle, only that particular light is actually going to have its rays actually separated and be absorbed. So only light that hits our sphere from this angle does it actually shine back only the green portion and absorb the other rays. Light that hits our sphere from every other angle, and every other angle that we look at our sphere from, has the light simply being just bounce back perfectly. Only from this particular angle is the light warped enough to allow this color to show through. Now, again, how do we determine how much the light is warped to allow this color to show through? That is entirely under our IOR mode, and we simply adjust that parameter here where we actually define ourselves at what angle is the light warped enough where we can actually warp that green light out of our sphere. And that light color is again determined under our specular parameter. Let's go ahead and make that gold color again. Type in a value of 50. Now, I know this is really overwhelming for you, and it was probably a lot more than you were expecting. But don't worry. This principle that we just learned is really going to help us and pay off in understanding more of the options that we're about to dive into. Now that we understand that by adjusting this value, we allow these colors and angles of the lights to show up defined by our own angle that we're setting right here, we now can increase this value even further. Now, as soon as I set this value to 1, though, we are now saying that any angle that we hit is rendered null, destroyed. There is no angle that the light can hit that is sharp enough to perfectly show through. Because remember, 0 is where any angle you look at shows through perfectly, whereas this is limiting it, saying, you know, only from this angle will the gold show through, right? We're limiting the color there. But if I take this all the way up to a value of 1, that means there is no angle hard enough for this to actually show through. There is no angle at a good enough area for this light to kind of warp in. Remember with our Octane glossy material, how I was saying that a value of 1 was very unrealistic, how it was not the most physically correct option when you had a value of 1 set because that was not allowing the light to show through as correctly. This is because now, in this case, we are seeing that is physically correct. And in that same case, just like how the glossy material should have been if it was going to be physically accurate, if I increase our metallic IOR past 1, we now are saying if light hits from this hard of an angle, now we're allowing it to show through. And notice the difference. Before, at this below 1, we are saying everything's purely reflective except for light that hits here. Then we're only allowing that color to come through. Now, if we go above 1, we're purely saying no light is going to reflect off of it at all except for at this angle. And if it does at all, it will have this color. So as I pull this value up higher and higher, I allow more and more of a reflection to show through. And as I can go higher and higher, I can crank this all the way up to 8, we are now having so many areas of this sphere where light can come through and reflect off of it and allow this reflection to show up. Now, I'm going to go ahead and add another little bit of information into here. If we go ahead and bring this back down to a value something like 0.2, right? I'm going to go ahead and start talking about this parameter right here. What this parameter does here is it actually creates a fall-off effect for our reflection, just like how real life would. If I start to increase this, notice it is literally kind of fading out our sphere's reflections. That's because depending on the angle that the light is being reflected off of this, there is going to be variations or a fall-off in that effect. So if I'm going to go ahead and drop this back down to 0, just like the angle that we are bending the light here depends whether this shows up, it is also now going to affect the strength of that parameter. So not only are we controlling that fall off determines what color shows up, but fall off also determines the strength of that effect. So no longer is it this perfectly hard kind of effect. If I do like 0.2, right? No longer is this perfectly purely reflective, boom, we hit this perfect angle, and now we see the golden light. That's just really not how it happens in the real world. Nothing is that perfectly hard of a distinction for that color. So we can add a fall-off effect. So as we come closer to this angle, it becomes stronger and stronger. So it's slightly, okay, we're coming closer, a little bit of gold, more. Imagine it kind of creates a gradation in this effect. This is very important for creating realism. Now, there's actually a name for these two different effects. This one here is referred to as N. This is your refractive index value. So think of it as more of a refractive index. So refractive index, this stands for N. And this value over here is actually referred to as K. This is the extinction coefficient. And coefficient is actually spelled with a C, but try and imagine it with a K. So extinction, K, coefficient. That's the best thing I can do for kind of helping you remember that. Quite honestly, it is the weirdest bit of names I've ever heard, and I don't blame you at all for feeling a little confused by this, but just simply remember, this slot here represents N, and this slot here represents K. And it's important to remember that because we're going to be mentioning these values in much more detail coming up in this video. So now that we understand this concept, though, of the angle that we determine for the reflection to show up and the angle that allows this effect to become stronger, create like a fade or fall off on that effect. So it's real strong here, but then beyond that, it starts to fade off. So we actually give it a little kind of a gradation on that. We now can understand the concept of finally moving on to the RGB plus IOR system. Now, as soon as I twirl this open, this is going to get very advanced very quickly. And this is actually what I've been prepping you for this entire IOR mode conversation. All this talk about refraction index, extinction coefficient, how light is absorbed and refracted and all that. It has all led up to this. So this is the big moment. Don't worry, though. You can do it. This is actually going to be a lot simpler than you think it's going to be. And I'm going to walk you through this step by step, and you are going to master this parameter right here. So you'll notice that we have a lot more sliders here. Now, what's very interesting is if I go back to the index of refraction plus color, simply realize that these two parameters here, N plus K, have simply been duplicated 2 more times on each slot. So if I go to RGB plus color, we now have N plus K. We have another N, we have another K, and we have another N and another K. We now have 6 parameters and 3 lines of N's and K's. So why has it done this? Well, before, underneath index of refraction plus color, we are simply determining the entire refraction rate, right? What angle does the light have to hit for the refraction to show up? And what is the fall off of that, right? What is the fall off of that reflection capability? And then we determined our color simply by setting our specular color, right? Now we do that a little differently. Specular color has been completely disabled. If I go into here, no effect. This is because we're no longer setting some RGB value that we just randomly pick to get our correct colors. We are getting it as physically accurate and correct as possible. We are determining our colors based off of the angle of light that hits our sphere and what colors show up. Remember how I talked about before how every object you see in real world, just like say you see a blue sphere, kind of like this, a blue-greenish sphere, every color that hits this sphere, that white light, is completely absorbed except for the color that bounces back. So we are actually determining what colors are we allowing to bounce back. So if I pull all these to 0, we get a purely reflective light. Every color is allowed to bounce back. Every color is completely reflective. But if I take this green value and pull this up, notice it's turning purple. This is because I'm saying green is being absorbed. We're now allowing every other color to bounce back except for green, and we're actually taking green out of that light spectrum. The same thing can be for blue. If I pull blue up, what's going to happen here? We get a warm yellow color. I'm actually absorbing the blue light and only saying light that hits from this angle is being bounced back. And as I crank this value higher and higher, we're actually going to absorb more and more blue light until it kind of just blows itself out in this kind of extreme kind of wraparound blue that's almost coming out. So you actually are sucking away this color as you pull this value up. So blue, as I increase this value, we are sucking away the blue light, and any blue light that hits from this angle or more is just starting to get sucked away. And it's interesting. Again, you can see this kind of spherical pattern. The blue light is only being sucked away when it hits this particular angle, and we can go further. And again, here's our K value, our good old K value friend right here. As I increase this value, we start to fade off this effect, right? Depending on the angle that the light hits it, it depends on how strong that effect is. So we can start to fade into it. Now, taking all of that info that we've just learned, right? We learned that we have a green value now, a blue value. We might be wondering what this value is up here. This is actually red. Even though it doesn't say it, this is actually red. So this is red, green, and blue. Now, what's interesting is we can actually take this red, green, and blue info and take that info there, dial it in, and actually create a perfectly physically accurate metallic material with a proper fall off of that color's effect, right? Because we have our N value, our refractive index determining when that color will show up, at what angle it has to hit, and a fade off, that K value, our extinction coefficient, that will actually determine how that light falls off and how strong this refraction effect is depending on the angle that the light hits. So If we take all this info and we punch in the right value, we are going to have a 100% physically correct material for whatever we decide we want to make. Now, here comes the hard part. How do we figure out what to type in to actually make this physically correct metal? Well, luckily, there's actually a pretty simple website that you can find that actually shows you how to do this. This website is called refractiveindex.info, and it has a huge library of all these N and K values. And go ahead, look at this. Lo and behold, here's our N value, our refractive index, and here's our K value, our extinction coefficient, all right before our eyes. And this website has a large library, a plethora of options to choose from for getting the proper N and K values for different material types. So to get access to these, all you literally have to do is select 3D, selected data for 3D artists. This is data specifically meant for you and me, data for 3D artists that are trying to figure out what the N and K values of these particular materials are. So select this as our shelf. Next up is our book. We need to talk about what are we looking for our N and K values of. We're actually looking for metals. So let's select a metal. And then for our page, what in this book are we looking for? We're going to make some nice gold. And once we select gold, we actually have our proper refractive index value. We have our N and we have our K. Now, you might be thinking, okay, good. All I have to do is copy and paste this data into all the chart slots and we'll be good to go, right? Sadly, no, it's not that simple. See, every material in real life, again, is made up of that white light, right? And then it's spread out into those different spectrums, right? We've already talked about that. Now, there's one little bit extra I want to talk about that. The color of the light is determined by something called a wavelength. The wavelength of the light determines its color. So the reason that light changes color is because this pure white light hits this object, absorbs the other channels, and is refracted back out in that color. And the reason it looks like this color, like say we use, for example, blue or red, is because the wavelength of that light has been changed to represent that color. Now, I know you're probably really feeling overwhelmed right now. Don't worry, though. If we just click this little help slot right here, it'll explain everything perfectly. Again, light is determined by its wavelength. But basically, these light rays, the wavelengths of it, are determined in something called nanometers. That's what NM stands for, nanometers. This is a very, very small distance. It's actually one of the smallest distances that you can actually kind of measure, I imagine. And basically, if it's 400 nanometers apart, these waves of light, they show up as purple. But if they're a bigger value, like 700 nanometers, they are red. Now, what's interesting is we can understand now that, okay, different spaces in this light determines, these nanometer distance determines its color. What's super cool is every single material in real life, anything you look at, gold included, has a different wavelength of light that bounces off of it. Now, what's interesting is the refractive index that we have over here, this refractive index, our N and K values, change depending on the wavelength of light that we're looking at. Because remember, the wavelength that I said, if I said, okay, pull out a little bit of blue color in here, I'm saying, okay, if light hits at this angle, then this is the wavelength we need. So the wavelength at this part on my sphere is different than this part. So just like with gold, it's going to have a different wavelength for red, for green, and yes, for blue. All three channels are going to have a different wavelength value because, again, each channel represents a different fall off for that light. So to get a proper mix of gold, we actually have to have a mix of blue light, green light, and red light being absorbed and bounced away from our object. It's actually a hybrid of all of them. It's not a simple one value pump in. So we actually have to understand the wavelength of every single color value for us to understand how to get a proper gold color. Now, there's a good news here. We don't have to understand all these potential variables here because we're only looking for three. We need pure blue, pure green, and pure red. And that is something you might be like, okay, how the heck do I figure that out on here? Luckily, if we scroll down to the bottom of the page, and if you don't have the help manual, that's okay. I'm going to have this info in the description of this video. There is actually 3 key sets of numbers that we need to understand. And I think it is located towards, I think it's 450. Yes, it's right here. The red, green, and blue IOR values that represent perfectly in wavelength is 650 nanometers for red, 550 nanometers for green, and 450 nanometers for blue. The reason, just in case you're a little bit lost here, the reason that I'm actually looking for the distance is we have to match the proper colors for red, green, and blue to match the look that we're coming for on this website right here. Because we're trying to look for the proper refractive index for our red, green, and blue channels. So if I can find the proper reflective fall off for the red channel and the proper reflective fall off for the green channel, and finally for the blue channel, if we take all that data and we pump that into our material, we will have a 100% physically accurate sphere or gold colored sphere. So now that we understand why we're looking for these three colors, right? 650 nanometers represents red, 550 is green, and 450 is blue, right? Let's go ahead and close this. Now that we understand that, we can take this data and actually pump it into this chart right here. Because again, we have a wavelength. We have to say, what color am I looking for? What do I have to set my color as for this to show through on here? So I need my color to represent red, so I can find the N and K values for red and then pump that into this slot here. So how do we do this? Well, to type in red, I know that the wavelength is 650 nanometers. The problem is this value right here is something called That is the incorrect value. We're not looking for that. What I need is something in nanometers. So how do I do that? Luckily, we have a unit converter right here. So let's select it. And what we're going to do is here, lo and behold, is nanometers. So let's go ahead and type in 650. Once I do that, I'm going to select convert, and it has automatically converted this other measurement system, properly. So now it is exactly 0.65. If I press OK, we now have the proper refractive index of gold of 0.18299 for our refractive index, and our K, extinction coefficient, is 3.4242. This is the proper reflective fall off that we're going to get for the red color on a typical gold material. What's great about this is we can copy this data. Let's copy N, right? Let's do right-click, copy. We have 0.18299. Let's go ahead and paste this into the red slot on our N channel, right? Because this part here is our N, our refractive index. Let's go ahead and right-click and paste. Now, we need to have our proper K, our extinction coefficient. At what angle does this start to fall off? What variations do we have in that? Let's go ahead and right-click, copy this, take this data, put it over here, right-click, and paste. Now that we have this, let's go ahead and look for our green channel. And what was green? Green was a value of 550. So we can take our unit converter again, go into here, type 550, press enter, or we can just click convert, and that is 0.55. Press OK. Here is this proper refractive index. We'll take our N value right here, do copy. We're going to go back into here. I'm going to paste this into this channel here, and again, we're going to head down to our K value now, our extinction coefficient. Copy this value here, paste this into this slot right here, and now we're getting closer and closer to our proper gold material. You can see we're getting so close right now. We have one last spot to finish up with, and that is blue, and blue is a value of 450. So let's go to our unit converter, type in our nanometer size. We'll do 450, press enter, press OK, copy our refractive index right here, right-click, copy, go over here, take our blue parameter, right-click, and paste that. Finally finish up, or we're grabbing our extinction coefficient. At what angle do we have variation? At what angle does this start to die off? And this is that angle we're setting right here, and we're doing paste. And now, lo and behold, this, after all of that, is a 100% physically correct golden brick material here. Now, this may not look as bold and fancy, but this is much more physically correct in recreating gold than if we were using something like artistic, where we just literally just set our diffuse color and just literally set it to gold like this. This just is kind of fake looking. Realistic gold is going to be this. This is 100% physically accurate gold. And how do I know that? That is because we properly mapped in the red, green, and blue channels that our Octane Metallic Material needs to reflect those materials off. So we're saying, okay, we're absorbing this much blue, We're absorbing this much green, and we're absorbing this much red. So we got our blue, green, and red. And then that amount of absorption is entirely determined by pumping in this correct value that is scientifically accurate. So now that we have all this stuff pumped in, we actually have a physically correct golden brick or golden sphere here. And you can see that it is actually really well in replicating. Notice on the edges, we're getting a lot more pure white light coming in, but more towards the center, we are getting a much harder, stronger gold color. Again, this is determining by the angle that the light hits it to show up these colors. So this is, again, the most physically accurate as you're going to get to a gold material inside Cinema 4D. So if this is important to you, having physically correct levels of reflection and detail and color for your metallic material, this is the way to do it. I'm doing a quick little edit here for you guys. Now, if this all has been a little too intense for you and you're just like, wow, this is just way too much work, I'm feeling really lost, there's just no way I'm going to be able to take all this data and punch it in exactly like this, that is okay. That is why I have a preset of all the materials, metallic materials that is, that they have on the refractiveindex.info.com, all on that website, doing exactly what I just did, what I showed for you guys. I have all that preset up on preset materials, the ones you're looking at right now, everything from lead to gold to copper to brass, all 100% set up to be physically correct and accurate. These are perfect materials to just be a slap-on, looks good and decent, or it can be excellent building blocks to expand on these materials and make them look even more realistic, like adding bumps and normals and scratches and different levels of roughness and so much more detail. So if getting the proper refractive index is just too much work and it's really confusing for you and you just don't want to have to deal with it, don't worry, go ahead and use these presets. Now, at this point, this video is basically done. I am going to mention under the comment slot, we do have simple controls such as smooth, which will add smoothing, effect alpha, which has no control. This is only for specular materials. And we have rounded edges, where if I disable smoothing, I can crank up rounded edges, and we'll kind of create like this smooth effect. It'll kind of like bevel the edges of our material. This is something I talked about in a lot of detail on the other materials, so I'm not going to talk in too much more detail about this. I'll disable this, turn on smooth. Vertex map resolution, this literally will determine the level that a vertex map is being painted on. So if you have a vertex map that you're actually painting on this sphere and you're actually running a vertex map into this sphere right here, actually running a vertex map that you painted onto it, or this material, not particularly the sphere, but you have like a vertex map in this material, this determines the resolution. Is completely pointless because a value of 4 is as high as a vertex map supports. Anything above this does nothing, and you can't go below 4. So adjusting this is pointless. And C4D shader resolution. If you're loading in a C4D shader, as we talked about a little bit already, you might not be aware, but Cinema 4D shaders are actually converted to an image, and then, such as Cinema 4D noises, are converted to an image, slapped onto this material, and then that's how you're able to perceive it. So this conversion process, actually, since that C4D noise has to be baked into an image first, you actually have to determine what resolution. And this is what determines that. By default, it's whatever's in your settings, which I actually talk about in a later video. But I will point out that you can manually override that to something like, say, 2K, 4K, or even 8K. I recommend leaving this at default and adjusting that in your settings up here, but you can do this on a per material basis. But again, that's covered in an entirely different video. Finally, we do have editor, which lets us check this on to animate preview and our texture preview size in our live viewer here and our editor display. Neither of these actually function. Our texture editor display does not show the alpha or bump. That is what they're supposed to do. You can actually solo that in your editor display over here. Neither of these functions actually work at this time. Texture preview size lets you determine the preview size of your texture that you're viewing here. This also, I don't believe, actually works. I could test it really quick. We're going to go ahead and switch to a diffuse material. Go ahead and slap a noise into this slot right here. And I don't think it functions. They might have updated it. Let's go ahead and check it. We'll up this to 2K. And it doesn't appear that anything has changed. We'll go ahead and up the contrast on our noise. Still nothing. Nothing. And this is, again, C4D noise. Look how blocky it is. We can go ahead and up that resolution by changing it from default to something like, say, 1K. Boom, nice and clean. But how does it look over here in the viewer? Still like junk. Let's go ahead and up our texture preview size, say 500, nothing, 8K. It's actually having an effect. Okay, so this does work. You can adjust the preview size in your live viewer over here. Not something I would recommend, just because it's really going to slow down Octane. You're going to have to process over here, plus over there. Leave this at a low value, or don't do no scaling, because that will literally have a huge value. I'd drop this down to 16 if I was you. The less processing your GPU has to do in this viewport means the more it has available to do over here. But at this point, this video is basically done. This has been a massive, massive, intense bit of information that you have just gone through. So I thank you so much for watching this. I really do hope you found it helpful. We are going to finish everything up with a very, very light overview of what we just learned. In this video, we learned how to use something called the Octane Metallic Material. And we learned that one of the main reasons that you'd want to use the Octane Metallic Material is because it gives you access to something called the Index of Refraction Mode. We learned that real light in real life that hits objects absorbs all the colors of light except for that color that bounces off of it, like this gold right here. Every color is absorbed except for this gold color. We learned that light is also determined its color by its wavelength. The longer the waves, the length of that light, the redder it'll be, and the closer together it is, the more kind of purplish it'll be. And every other color in our spectrum is determined by every value in between, which we learned in this kind of little help dialogue here with this amazing little diagram. So 700 nanometers, kind of far apart, red, a little closer, 400, more purple. And we learned that we were actually able to separate these light waves, and by determining that angle, we can actually pump that into our metallic reflection mode. So by going through and actually determining what angle would we like to have this light absorbed, such as red, green, or blue, we can actually type in physically correct gold. So by taking that data, such as we learned 650 was for red, saying, okay, what does gold absorb in the 650 range? So light that is red, we typed in, which would be 0.65. So light that is red on gold, how much does it absorb it and at what angle? So at this angle, it absorbs at this much. And at this extinction coefficient, how much is this effect affected at that angle? And those angles are determined here. So that we have our N and K value, we put that into the correct ports. So for our IOR red, we had our value here for our N and here for our K. We're able to take that value and create a physically correct metallic gold material. Now we learned that we don't have to use this very complicated system. We could use IOR plus color, where the color that is absorbed, or rather the color that is left to bounce back, is simply determined under our specular option up here, even though this isn't technically physically accurate though, right? Because we're actually saying yellow is the color that you're not going to absorb. So before we were actually determining the absorbed colors, which was more physically accurate. Now we're actually saying the color that is left, which is this gold or green or blue or purple or whatever you'd like it to be. And then finally we have the simplest mode of all, which was artistic. You literally have no control over these parameters whatsoever, and you simply just set it to whatever you feel like dropping the little slider on, and you do all your controls with your specular and other control parameters there. We also learned that the metallic material was very particularly special in the fact that none of the diffuse controls show up whatsoever unless your specular map is pulled down. Specular map determines what actual color can show through on your diffuse. So if you have your specular value maxed out at 1, we cannot see any diffuse whatsoever, which includes our sheen layer, because remember, sheen is part of the diffuse layer. So if you have your specular map maxed out, this is entirely a reflective metal material with no rough diffuse base coat whatsoever. If I remove this, go back to 0, take my diffuse slot, or clear this out, take my sheen layer and start adjusting the roughness, you can see the effect being applied here, as you can see like that. So again, our specular map determines the amount of specular reflections that we get. Even if you have your specular set to pure black, or drop your float down where you have like literally next to no reflections coming off, you still get a little bit because we do have our index value still set for it. You see that we're still basically losing all color, and that's because we are still saying this is reflective and we are not reflecting anything back. But the diffuse only shows up when you actually remove that specular capability. And again, we learned that we can pump other values in here, such as like a noise, to create really cool contrasty results for having reflection or no reflection. So we can crank up our specular amount on here, take our specular, drag it up, and now we got like a really cool diffuse specular kind of mix. So this is really great for creating rust and stuff in your scene. This is kind of taught here. A really great example is this dragon right here. There's a rust diffuse layer that was created. So under the diffuse, he created like a rusty kind of look. And then for the specular parts, he did different controls for that. So you can actually morph between the different kind of rusty areas where there's less specular capability. So he took the specular map down and got rid of that using some type of noise or dirt. And for the metallic part, he left that there. So he's able to morph between the diffuse coat, that rust, and the metallic coat. At this point, though, this video is done. And the first thing I would recommend you do is give yourself a big pat on the back. Because if you have just completed one of the most complex videos in the Octane Master Course, as we've gone over some really intense subjects that are really difficult and hard to learn and wrap your head around. So if you're still feeling a little bit confused, don't feel bad. Feel free to watch the video again, because again, this has been some really intense and complex subjects to really try and understand. So definitely don't be afraid to go over it again. But again, thank you so much for watching. I really do hope you found this helpful, and I cannot wait to see you all in the next video.